So, yeah, my name is Martijn Handels. I'm with Rollos. I'm the director of product development. I'm also one of the owners of the company, and we're here today to talk about one of the products we've developed for the drilling market and the interactions we've had with the Edge Data Store and the development teams that have been working on that. So, Chris Feltz. I guess if you're here, you're probably interested in that component. So I don't know if everybody knows what the Edge Data Store is. Yeah, so I'll talk about what we did with it and the reasons why we incorporated it into this product. So a little bit about Rollos. So my two other partners have a background in aerospace engineering, and Rollos is actually a family-owned business, a third generation, so it's 70 years old. And we acquired the company 4 years ago with the intent of buying an installed base. So Rollos traditionally provided CCTV camera systems to offshore drilling contractors. Now, instead of having a startup and innovating in that kind of way with a new product, we bought the company to be able to innovate on top of existing customer relationships and issues that were coming directly from our clients. So we've evolved into a company that helps people with remote assets manage their central storage and access to data. So we see it as like an airplane fleet. You know, if you own a lot of assets that go around, it could be ships, drill rigs. They don't have good data connections to shore. And what we do is all of our solutions are focused around giving an end-to-end solution to help customers actually centralize that knowledge and experience in one place. So what we've done with the company is still do the CCTV, but for us the CCTV is no longer traditionally cameras. It is a smart sensor. So we add deep learning algorithms, real AI. It's not some simple algorithms. This is a full deep learning stack that can actually do smart things on top of video. And that's the main topic of the product that we're talking about today. That's the first core pillar. The second one is data analytics. And this is how we partner with Pi. We build custom data analytics solutions on top of Pi. So we also combine time series data with documentation. We have a tool that can actually take information from documents and manuals, and if an alert comes out on one of the Pi systems, we can actually tie into the maintenance management systems and have the most relevant documentation to that piece of equipment with the actual time series alerts. And then the last one is, in order to make use of smart technologies, you need full connectivity. Now, on most offshore locations, especially non-new build rigs and vessels, there's no full Wi-Fi. And if you want to put full Wi-Fi on your platform, there's a lot of steel. And it really attenuates your signal from classical Wi-Fi. So what we do is we set up our own private LTE network. So we've got like a Verizon in a box. We've got a mobile one that we can actually carry around. And we have a full setup for the rig. And that allows us to tie the other smart solutions we do to really get the people to have that information at the asset. So in the thruster rooms or at the asset on the drill floor. And that's when these technical solutions actually start working, when everybody has access to them on every place of the site. We don't do this for all markets. We focus on offshore, oil and gas. Main customers are drilling contractors there, but we deal a lot with oil companies as well. And especially for this solution, we're seeing that drilling contractors and oil companies are actually teaming up to put a system like this in place. We do this for offshore wind, mostly the substations that actually gather all the tie-ins of the electrical, and the special marine. And special marine is very big in our country. We are based in Holland, in Rotterdam, close to the harbor. And these are companies like the lifting companies, the Hirma's, the Allseas, the Huisman. It's very big in our company. We do the digitization for a shipbuilder in the Netherlands called IHC. So these are our three market areas. So, what are we talking about? Anybody know where this is? Yeah, there we go. 3 years ago, we had one of our customers approach us, and they actually had an issue with the safety incident. So you see a lot of large equipment here. This is an empty floor, but normally on the left-hand side there's actually full of drill pipe. And that yellow device there picks up that drill pipe. Now, what happened there is the system that keeps these drill pipes in place is an open loop system. It's got valves that open and close, and there's no feedback to the person driving that big crane to actually tell him that the latch is open. So there's people looking up and giving visual confirmation. So one of those latches failed, and actually when they start pulling out the pipe, they pulled it through this latch, and the pipe actually broke off the latch and hit somebody in this back area. And there's two things that went wrong there. Somebody missed the person, and he shouldn't have been there in the first place. So they asked, we do not want to repeat this event ever again. So can you come up with a solution that can keep track of people on the drill floor and their position with respect to the equipment? And this is one of the earliest versions. We explored different types of approaches, like RFID tags, other technology that can do spatially aware measurements. And in the end, we boiled down that camera systems were the most robust. We have a lot of experience with them, so we can combine our knowledge of the industry, the camera systems, and the data science to actually get it to work to analyze this video in real time, because that's the hard part. So this is one of the first tests we ran. The drill floor is still by far the most dangerous place on the drill rig, period. And the difficult part there is that it's a dynamic environment. You preferably have no people on there. And we're getting out there with rigs that are fully autonomous with automated stop systems, but we're not there yet. And there's a whole fleet of older rigs that are still operational, and they require people to be in an area where heavy moving equipment moves around. So there's three sort of major risks. It's being in the line of fire, something very heavy. The second one is getting caught in between something, a hand gets stuck somewhere. And there's a big drill tower on top of the rig, and there's a lot of heavy equipment up there, and there's a potential for things dropping down. And if something that's maybe a kilo weight drops down from 20 to 25 meters, it's actually lethal. So that's the issue. So what we need to do is we need to have a system that allows the person that drives the rig, the driller, to have continuously awareness of where his people are without real human interference. Because if you have somebody doing a tedious task and having to look and do visual cuts, mistakes happen, right? So we started with the main goal. It was to detect people, locate them, and then send alarm and alerts to the people that needed these alarms to see where people were. So those are actually the top two. As we developed the product, we started gathering more and more data. So we got people data, location data, and that gave us the capabilities to actually start analyzing the way we work. So if you don't measure something, you don't really think about how your operation goes. There's standard operating procedures, but because it's really hard to measure how people move on the drill floor, you don't really have a fixed way of thinking about it. So with some of our clients, we realized that they didn't really know how to define which areas were risky and which weren't. So we started doing an analysis of the procedures they have. And now that we have all this information and we can combine that with some of the equipment outputs, so a lot of the drilling contractors are also getting onto time series data, they track it, they keep track of how they perform with their crews. We can actually now add the human element to that, because we can actually track it from video, and we can combine that with the output from the equipment data and improve efficiency even more. And then we can stream that data back to shore using the Edge Data Store. So we'll focus on the alerting part here first. So how does the system work? This is a large drill floor. We've actually put several cameras up. So one of the hard things that people had tried to do this before is they put cameras on eyesight. And if you do that, then if people are standing in line of each other, it's actually really hard on a vision-based system to actually pinpoint where that person's been. And that's the key thing. We need to do that. We need to do that with high accuracy. We need to exactly know. So that fails when you put the cameras like this. So we went back to the drawing board. One of the advantages of doing it at a high site is there's many algorithms out there that can easily detect the person front face. I mean, Google, Facebook, all these, you can get open source libraries. It all works. But the triangulation part was really failing. So we went back to the drawing board and figured, okay, what do we need to do? We need to pull the cameras up. So we're putting the cameras at 10 meters above the drill floor. Makes it harder to detect people at first. So we had to really retrain the standard-based algorithms. But once we got that, it's actually very robust and it works really well. So we've got 16 cameras on top. Then the driller has a very simple user interface. These guys are already overloaded with 10, 20 screens. They have to look at everything. So when we first said we were going to introduce an additional screen, they said, no, not another one, not another alert. So we really sat with them and we talked through like, okay, what would be the least intrusive for your work? So we've got a very easy touch-based system where we predefine the zones that we consider to be red zones during which operations. And then the driller can either use the touch screen to activate that zone, and then the operation starts. And as soon as somebody moves in and there's a breach, an alert will go. It will start flashing. So the guys never see any camera images. They just see dots and pigtails. So they see where everybody is on the floor and whether they're in a red zone or not. And then if somebody breaches, we've got audio alerts and a flashlight system. And I have a short demo to display that a little bit better. So this is actually the system at work. So the driller never sees this video on the left-hand side. It's just for explanation purposes. What he does see is actually the screen on the right. And he's just pressed to start activating it. And there's a stoplight sign on the left-hand corner, which starts flashing that it's actually being activated. And as soon as somebody now moves into the zone, it actually starts breaching it. So he gets an alert. So it's very simple. I like, because everything behind this is true AI, right? It's some serious computational calculations going on in the background. But the end result is very simple. You just need to make AI work to do what it does for you, and then don't focus all the technical details in behind. You want to just, that's the way I see this technology applied. So on the left-hand side, you see a screen where we're only identifying people. That was what we started with. We can now also identify the equipment. But the disadvantage we have is that we actually lose sight of the equipment as soon as they go out of our camera image. So we needed integration with the control system. And we also need the integration for the control system to automatically start activating which zones are red zones and which aren't. So we need access to the control systems. Now, we do this with the classical ways, the OPC interfaces, the Modbus interfaces. And what we were looking for is a piece of technology that could help us out there. So what we can do from having the combination of the equipment data and the people in position data is we can, like I said, control activation, but we can also start doing really fancy reports on the performance of people and their safety behavior. And we can start analyzing movement. We can do heat maps. We can see, hey, maybe this operation isn't so optimal. Somebody is continuously standing in a dangerous spot, and then when you go to the drill floor, you see maybe somebody put a piece of equipment there that's not really rightly placed. So that's one of the extra things we can do, and we can start identifying incidents. Somebody touched the tool, or what's the operation they're actually doing. So the algorithms are getting so smart that we can actually say, oh, during this period they were changing out a bit. So we're starting to add segmentation to the scenes, not just people detection, but we're actually doing, say, what are you doing at the moment? And then you can make like an event frame during which period they were doing that. So that's where the Edge Data Store comes in. So we started talking with OSIsoft and thinking we sell OSIsoft to our customers, so we thought we need to eat our own dog food. So that's where we started to incorporate this Pi technology into our product. And a Pi server was just too much. We don't need that many tags. And we needed something that was microservice based. We needed to be sure that we could get any protocol in. So Edge Data Store comes with a couple of connectors. At current moment, it's Modbus and OPC UA, which is fine, but we also want to have the capabilities to stream in IoT type of sensors. If we need to combine that to make our solution smarter, we have OMF, the OCSoft message format, to actually pull in protocols that are non-standard. It's fully scripted, so our entire backend, and I have an architecture slide in the next one. We run everything in microservices, so we can spin up what we need in our architecture when we need it. And actually, the EDS has this functionality that you can fully script it. So it's less user friendly, but when you want to build something that's maintainable on a rig, it's actually really helpful that you can script all configurations. So it supports the Docker, any OS, so we don't need to worry about Linux or Windows. If we want to run it in another environment, we don't have to think about that because we know it allows you to do that. And then anybody that's ever tried to connect things on a rig that come from different systems knows there's time drifts everywhere. You might have a unified PLOC PLC that keeps track of your time series data, but we are doing computations on people location that are feeding in IP-based camera systems, analyzing that data, dumping it in a database somewhere. So you want to actually, to avoid time synchronization issues, store that data from our backend systems in the same database as you do from the time series outputs that is coming from the equipment. So we basically needed a mini historian on board, and that's where and then when you code against it, the code base is actually similar for OCS, so OCSoft Cloud Services. So it's not identical, but if you want to if we build out our UI, we actually can use one code base to actually spin it up on Edge, but also spin it up against OCS. So it removes the need for two different code bases for the development we do. So where we started out with making a solution that just did a safety system for drilling rigs. So red zone management is now turned into a complete platform. So it consists of several components. So we have a full CCTV system with a video management system, storage. It's a separate block that we can use. Then there's a deep learning server. So it's a pretty hefty beast going out with GPUs. There's several reasons to actually compute on Edge, because when it comes to video data and having the low latency, so we do 500 milliseconds from actually the algorithms picking up the data on the cameras and feeding it back into the driller. So if you go out into the market and check which deep learning algorithms actually work that fast, there's only a few. So we have a server there that can do vision-based analytics with a framework. And the advantage we have now is that we can add an additional camera. We have all the storage. So if we want to do a new application, say we want to start analyzing data from an ROV to detect something with a pipe down underneath the water, we can actually take the recordings, we can offload them from the rig, and we can then train the algorithm in a shore-based situation where you have more compute power. Once the algorithm is trained, the heavy lifting has been done. The training is the hardest to do with deep learning. So we can take those recordings, train the algorithm on shore, and then all we push back is the configuration of the deep learning algorithm, and then it can actually run on Edge. So you've created a platform for vision-based analytics. Then our full backend speaks MQTT. So we have like a universe protocol, and we use OMF to push it into EDS from our outputs. And then we can use the standard interfacing to connect to the drilling control system so that we have it in one place. And then we have a couple of endpoints, so we can code our UI, so our user interface, against EDS. So it will call and have our visualizations be run on the Edge data store. And then we can feed it out through OMF to either a Pi server. So, and that Pi server can be then connected to maybe a Pi server, one of our clients, through Cloud Connect or a third-party application. Because we've opened up the data that's coming from our systems to everybody. It's not a closed system, so we're sharing in and out. So if we want to build smarter things, we can do that. We can feed it out to OCS, and then we have our user interface, like a central management dashboard for all the rigs. And yeah, like I said, we have the capabilities to feed off the videos. And now this is example of our most recent dashboard. So it probably looks like, if you're not in drilling, a bit abracadabra, but what we can now do is really start benchmarking things. We can see how many red zone breaches have been during which shifts. We can start actually analyzing the behavior. So there's three key stakeholders that are really interested in this type of statistics. It's the drill crews to improve their performance and safety records. It's the end customers that really want a record of the safety behavior on board. So the safety reps actually love this because they have they can change their operations and trying to make them more safe, but you now have a tool that can actually measure if it's improved, because we can see how people have been behaving, and then the next month, once you've made a change because you thought the operating procedure was slightly suboptimal, you actually have the capability to measure it, and if it doesn't change, you can actually act on it. So we could do per shift, we can do per rig type, you could see maybe based on different equipment. So it's really given us much more than just an alerting system for keeping people safe on the drill floor. So I think I'm a bit quick, but that's me. If there's questions on either how we worked with the development teams, because maybe that's something I haven't mentioned. It's been great working with Chris Veld's team, and the lines are really short, right? There's a lot of iteration cycles, but we've really enjoyed working with the development teams directly, and yeah, I can encourage anybody that wants to try out these new things that it's really nice to work with the teams. So thanks for your attention. Any questions?
Thank you so much. I wanted to just ask how you transfer the video and audio data. Are you doing edge processing, for example, just transforming it into a vector and transferring the vector, or the entire video to the cloud?
No, we don't go to. We only go cloud for new applications. Or actually, we've got quite a few servers ourselves for the training, because it becomes quite costly and cloud easily. So everything runs self-sufficient on the rig, but if we need to transfer vast amounts of video data, so the red zone system, everything stays on the rig, everything. There's full edge. If we want to, the example where I said I want to train a new application, we would probably still offload with disks, because it's gigabytes and gigabytes of data. So we can take it from the video management system, then we upload it into our systems onshore. We retrain the algorithms to do something new, and then the only thing that goes back is the weight of the deep learning model. And then we know we have the right recordings, so the right latency, we know the pixels, we know everything, because our video management system is controlled by us. And then you press play, and you got the new deep learning. Yeah, everything's edge. Everything's edge. Yeah. And it's the only way to do it. People thinking about unlimited bandwidth, I always kind of laugh. I thought maybe by now Google would have put the balloons out, or Elon Musk, and it's taking much longer.
Thank you very much, Martijn. Really cool cutting-edge stuff you have here. Maybe you can say something about how easy it was to work with the EDS environment, and what you needed to do to learn to work with it.
Yeah. So for us, we do two things. We develop our core products, and then if we want to try something new, I have like this sort of rule: if my guys can't figure it out in half a day, and we're on this tight deadline, we focus on the core development process, and EDS just came alongside because we needed an historian on board. And yeah, I think Chris sent us the installers. We went through the API management, and I think an hour later, I had it spun up on a Docker container, and it was talking to a Modbus simulator. So I figured, okay, we're gonna work with that. So for me, that's been really part of why we jumped onto it, and cause we've worked with the other beta teams before, and sometimes that's a little bit harder but this EDS was really easy to do. So yeah, that's been one of the reasons why we also selected the way to go like this.
Okay, cool. Thank you.